Hey everybody, welcome back to Dave's Math Channel. I'm your host David Tare, and this is my continuing feature on the Math Lovers book. This is going to be my last lesson of section 3.2 on irrational numbers, and today I'm going to talk about exponential numbers and logarithms. This is the last type of specific type of irrational number I'm going to talk about. I already talked about pi and square roots, and actually there are some others. I'm going to talk about the golden ratio later, but that's the next section. So anyway, let's just begin. What are exponential numbers and logarithms? Well, um, there's a special number in math called Euler's constant, given the symbol e. It used to be called the base of natural logarithms. It's a very important constant in mathematics, probably second most important after pi, actually. And the value of e is approximately 2.71828182885. It looks like it repeats, but it doesn't. It has the four digits 1828 repeated a couple times, but that's just a coincidence. But it is a very important number, and it has a much more complicated definition than pi. Pi is just the ratio of the circumference to the diameter of any circle. The definition of E, to understand it, you really gotta have to know a little bit of calculus. So I'm not going to try to explain the definition of E in this video. I do, in my second volume, I do go into much more detail on exponential functions and logarithms. Here I'm just introducing the number E. It's another, just suffice it to say, it's another very important irrational number like pi. And irrational meaning that it can't be expressed as the ratio of two integers. And it's pretty easy to prove that it's irrational. As a matter of fact, the proof is even easier than the proof that pi is rational. Actually, the proof that pi is rational is pretty complicated. It's more complicated than the proof that square roots are irrational. Square roots are numbers that aren't perfect squares, but it's not too bad. Once you know what E is, once you know a little bit of calculus, you'll see it's very easy to prove that E is an irrational number. It's also a transcendental number, by the way. Like pi and E are both transcendental numbers, and I think I already said that transcendental numbers are kind of the norm among irrational numbers. Most real numbers are irrational, meaning the ones that are rational is a set of measures zero. In other words, if you just picked one at random, the probability you picked a rational number would be essentially zero. Well, the same is true of algebraic numbers. It turns out, even though there's a lot more algebraic numbers than rational numbers, there's also still a lot more real numbers or irrational numbers, if you like, just the one or transcendental numbers, the ones that aren't algebraic versus the ones that are. So it shouldn't be a surprise that E is a transcendental number like pi. And the other numbers that are transcendental, I mean, it's easy to go from exponential e to the x. There's a function called e to the x. It's kind of the exponential function. Actually, there's a lot of exponential functions. B to the x, where b is any positive real number. You can make a what's called an exponential function b to the x, and it has a lot of very useful properties. It's a very rapidly growing function, by the way. And the bigger b is, the more rapidly it grows, or if b is less than 1, if b is between 0 and 1, then it's an exponentially decaying function. I'm going to get into this in much more detail. I think this is like in chapter 12 of my, it's in volume 2, so I don't want to go into this now, but this is a little bit of a heads up on that. But there's another very closely related function to exponential functions known as logarithms. And logarithms, if you like, are just the inverse of exponential functions. So when we say y is equal to e to the x, with another way of saying that is x is the natural logarithm of y. The conventional notation for natural logarithms is ln. We say ln x for the natural logarithm of x. I write in my book, I write as log. And actually, there are a lot of mathematicians, particularly advanced mathematicians, who prefer to write log instead of ln. And there's even a lot of mathematical software that uses log rather than ln. I prefer log, But unfortunately, the convention with log is usually when we write log, we mean what's called the common logarithm or the base 10 logarithm, just because it's a little easier to work with conceptually. But ln turns out to have a lot more useful properties. You'll appreciate that a lot more once you learn some calculus. But anyway, and the other thing that the other numbers that turn out to be irrational, transcendental, as a matter of fact, lnx. Whenever, and before maybe I should back up a little bit. Not just as e irrational and transcendental, but it turns out that e to the x I think for any rational number x, not just rational, I think for every algebraic number x, e to the x turns out to be transcendental. And actually, you can use that fact to prove that pi is transcendental. That's how it was proven that pi was transcendental. Um, but and not only that, but natural logarithms are transcendental too. It turns out that when x is any irrational number other than 0 or 1, uh, I think those are the only special cases. The natural log of 0 is undefined, by the way. But the natural logarithm of 1 is 0, kind of the definition of logarithms. I mean, e to the 0th power is 1. Anything to the 0th power is 1. So therefore, and when you take the inverse, the natural logarithm of 1 is just 0. But take any other rational number, like any integer, like 2, natural logarithm of 2, that turns out to be irrational, not only irrational, but transcendental. I believe it's true that natural logarithm of r, where r is any rational number, the natural logarithm of r is always transcendental. That's not true for common logarithms, by the way. Common logarithm of 10, log 10 as it's usually written, is equal to 1. And log 100 is 2, and log 1,000 is 3, and so on. But when you're doing natural logarithms, they're all irrational. Unless you have a special argument like e, ln of e is 1, ln of e squared is 2, and so on. But anyway, these are just other types of irrational numbers that you see a lot. So that concludes my video for today on exponential and logarithmic numbers. And thank you for watching, and long live math, and I'll see you guys next time.